Good afternoon, my dear students. This is Basic Science class with Teacher Peace Odinaka Chukwu. Trust you are all doing good. It is interesting to know that we are going to be completing everything about simple machines. Remember, for the past few weeks, we've been discussing simple machines. So for today, we are going to be discussing the remaining types of simple machines. We are going to be talking about inclined plane, wedges, pulley, efficiency of machines, and maintenance of machines. So by the end of today, you should be able to 1. Explain inclined plane, pulley, and wedges. Should be able to explain the efficiency of machine, and you should be able to state at least 3 ways of maintaining machines. Let's now look at what an inclined plane is. An inclined plane, as we all know, is one of the types of simple machine. Am I right? Good. An inclined plane is a simple machine with a slopy surface used to move an object to a higher or lower place. The key word here is what? Slopy surface. An inclined plane is that type of simple machine that has slopy surface. When we are talking about slopy surface, that means it has slope, and a slope is an area of ground or object that turns evenly upward or what? Downward. So inclined plane helps to move an object to a higher or lower place. Examples of inclined plane are ramps, stairs, just like the ones we have in our houses, slides. You can find slides in playgrounds. We have ant hills, slanted roofs, escalators, etc. All these are examples of inclined plane. Let's now see the pictures of what we are talking about. You can see what we are talking about here. This is a slide, a skateboard ramp, wheelchair ramp, airplane wing, and carpenter's plane. They are all examples of what? Inclined plane. Remember that we said that an inclined plane is what? A simple machine that uses what? That has a slopy surface. It has what? A slopy surface. That is what you should know for inclined planes. We are going to talk about the next one, which is what? Wedges. What is a wedge? Have you heard the word wedge? A wedge is a simple machine that works on the principle of inclined plane, used for lifting, pushing, tightening, and splitting objects. When we say that a wedge works on the principle of inclined plane, we are saying that a wedge is made up of 2 inclined planes that meet together to form a sharp edge. This sharp edge of a wedge is used for lifting, pushing, tightening, and splitting objects. Examples of wedges are knife blades, chisels, pins, and the blade of hatchet or axe. Look at what we are talking about. You can see the object that is V-shaped. Wedges are usually what? V-shaped, because the planes meet together, forming what? The sharp edge. Okay? Uses of wedges include 1. They are used to lift things. 2. Separate things. 3. Tighten and attach things. That is for wedges. You can see other examples here. Axe, knife, stopper. Stopper is used to prevent objects from moving freely. You can see the picture there. A stopper is used to prevent door from opening on its own or from closing on its own. That is for wedges. Now the next one is pulleys. Pulleys. A pulley is a simple machine that uses grooved wheels and a rope to raise, lower, or move a load. Remember, I said earlier that you have to know what differentiates one type of simple machine from the other. We've talked about wheel and axle, and when we were discussing wheels, we noted that wheel have how many wheels? They are made up of two wheels. So for pulley, it has grooved wheels and a rope. That is what you should know. This is what we are talking about. You can see the load here. This is the grooved wheel, and this is the rope. Are you following? That is what I want you to know. Okay, we have three kinds of pulley. How many kinds? Three. You can call it kinds, you can call it type. The first one is fixed pulley. The wheel is attached to a fixed location. That is for fixed pulley. It has the wheel attached to a fixed location, making it impossible for it to what? Move. The second one is movable pulley. The wheel is attached to what? To the object or to the load. The third is block and tackle. Block and tackle is the combination of fixed and movable pulley. So for block and tackle, how many wheels will it have? How many wheels? It's going to have 2 wheels. Let's see what we are talking about. Can you see the picture here? This is the object or the load, and this is the wheel, fixed in where? A fixed what? Location, attached to a fixed location. That is for fixed pulley. The wheel is attached to a fixed location. Okay, this one is what? Movable pulley. This is the load or the object, whereas this is the wheel. The wheel is attached to the load. The wheel is attached to this load. Now this is the fixed location, but here you can see that the wheel is no longer here but here. Are you following? Now this is the third kind of pulley, which is the block and tackle, and here it has 2 wheels, 1 and 2, telling us that block and tackle comprises of fixed pulley and movable pulley. Is that clear? All these are examples of pulley. They are all examples of pulley. There is no specific name for them. They are all called what? Pulleys. Now, whenever we are discussing machine, there are some terms used. One of them is mechanical advantage. Mechanical advantage is the ratio of the load to the effort. When we are talking about mechanical advantage, we say that it is used to assess the performance of machine. It is used to do what? Assess the performance of machine, to show how the machine performs or does its what? Work. The formula for finding mechanical advantage is giving us load over effort. Now listen, for your level, we are not going to solve any problem involving mechanical advantage. In your higher class, in your physics class, you are still going to be taught simple machine. Then you will solve numerous calculations involving mechanical advantage. Just know that the formula for finding mechanical advantage is what? Load over effort, while the definition is the ratio of the load to the effort. Do you get it? Okay. The next term used in machines, or whenever you are discussing machine, is what we call efficiency of machines. Efficiency of a machine is the ratio of the useful work done, that is the output, by the machine to the total work put into the machine. When we are talking about total work put into, we are talking about energy input, your effort. Okay, the force you applied on the machine is what we call what? Energy input. So the efficiency of a machine is the ratio of the useful work done by the machine to the total work put into the machine. Whenever you hear efficiency, it talks about a particular thing, be it object, be it a machine, doing or serving the purpose to which it was created. That is efficiency. So efficiency has to do with what? Doing what you are supposed to do. Doing that thing you are made to do. That is what efficiency is all about. So for you as a science student, you should know that it has to do with what? The ratio of the energy output to what? The energy input. That is for you as a scientist, okay? And it is always expressed in percentage. In your higher class, you will also solve problems involving efficiency of machines. Never you forget that efficiency of machines is always expressed in what? Percentage. And the formula for finding the efficiency of machine is energy output over energy input times what? 100%. And now listen carefully. Efficiency of a machine is always less than 100%. That is to say that no machine is 100% efficient. What did I say? No machine is 100% efficient. Do you know why? Let's see. This is because efficiency of machine can never be 100%. Why? Due to loss of work in overcoming friction. What is friction, if I may ask? Friction is what? A kind of force that opposes motion. Friction opposes what? Motion between two bodies in contact with each other. Okay? That is what friction is all about. So efficiency of machine can never be 100% because of what? The loss of work in overcoming friction. When we are talking about loss of work in overcoming friction, it means that the energy the machine could have used to perform or to do a particular work is used to do what? Overcome friction in order to allow it to do what? Move. Remember, we said that friction opposes what? Motion. Motion has to do with movement. So for a machine to move, it has to do what? Overcome friction first. To make sure that it can move freely, it has to do what? Overcome friction. Friction opposes movement. Okay, and in doing so, energy will be what? Lost, making it impossible for machines to be 100% efficient. Okay, we are going to be talking about maintenance of machines. How you care for your machines so that they last longer for you. The first one is regular servicing. It's important that you service your machines regularly. This is to do what? Avoid damage or avoid what? Creating problems for yourself. It's good to service it whether they are faulty or not. You don't have to wait till your machine develops fault before you service. You service it often and on. The second one is greasing or lubricating what? The moving parts. Greasing or lubricating the moving parts of machine. This is done by using what? Oil. Why do we grease or lubricate moving parts? Do you know why? This is to do what? Reduce friction. Okay. The third one says regular removal of dirt from machines. Machine that has lots of dirt will not be able to perform work properly. The fourth says regular checking for early detection of faults. When you check your machines regularly, you'll be able to detect faults at the early stage, thereby saving yourself money. Because when the faults are detected at the early stage, you can be able to do what? Repair them by yourself. But when you wait until it develops to a bigger fault or problem, you see yourself spending lots of money. Okay? The last but not the least is machines should not be left for a long time without warming them. How many of us have heard our parents saying that they want to warm their cars? Okay, this is what we are talking about. Warm your machine whether you are using it or not, so that what? When you want to use them, they will still be in good shape. Are you following? Okay. Remember, we've been discussing simple machines. If you've forgotten what simple machine is, let me tell you. A simple machine is a machine with few or no moving parts, which makes work easier. And we say that we have how many kinds of simple machine? 6. Lever, wheel and axle, pulley, inclined plane. This is the inclined plane. This is what? Wedge and what? Screw. These are the 6 types of simple machines that we have. Remember, we started talking about what? Inclined plane. We discussed pulley and we also talked about wedges. We went further to talking about what mechanical advantage is. We also talked about efficiency of machines and we gave reason why no machine is 100% efficient. Hope you are following. Okay, now let's assess ourselves to see if actually we've been following the lesson. Okay, we are going to do this. Match its name with its picture. We have the different types of simple machine here, and we have objects or pictures, okay, belonging to each type of simple machine. Okay, the first one is pulley. Which object here is a pulley? Do you know? Which object here is a pulley? Can you answer that? This is what? A pulley. This is a pulley. P for pulley. Which object is an inclined plane? This is an inclined plane. This is a slide. Which object is a screw? This is what? A screw. Which object is a wheel? This is what? A wheel. Remember when we discussed wheel. The next one is what? Wedge. An axe is an example of wedges. The next one is what? Lever, not level, please. Lever. A scissors is what? An example of lever. Thank you if you got all the answers correctly. Now let's move on. The next question is, explain the following: inclined plane, wedges, pulley. Next one is, explain the efficiency of a machine. The fourth, state 3 ways of maintaining a machine. I believe that you can all answer these questions without blinking an eye. Now, this assignment is for you. 1. State why no machine is 100% efficient. 2. Give 2 examples of inclined plane. 3. What is mechanical advantage? This is where we'll be ending our lessons for today. I believe that you've all written your notes and you understood everything that we've discussed. If you've not, please, I urge you, go back to your notes, read them. If you have any question, you ask using our feedback channel. Remember, do all your assignments and forward it to me. I want to acknowledge those that have been sending in their answers to the assignments given to them. Thank you very much. See you next time. Goodbye.